Hi everyone, and welcome to the second video for Unit 6 on energy resources. Today we're going to dive into fossil fuels, learn a little bit about what they are, how they work, and why we use them. There's a lot of controversy around them and a lot of sort of social stigma in terms of them being good or bad, so we're going to pick that apart today. So first we'll talk about what they are, get into how they work, what we use them for, the different types that there are, what impacts they have, and why we even use them. So we're just going to really break this down for you. So fossil fuels, first of all, are made of organic matter that has decomposed, been compressed under high heat and pressure for hundreds of millions of years, and gets converted into some sort of fossil fuel. It could be coal, oil, or gas. It's usually plant matter that has been fossilized and like I said, gets compressed, and it usually ends up forming sedimentary rock. Under high heat and pressure, layers and layers of decomposing material get compressed until it's just the purest hydrocarbons, carbon and hydrogen-based molecules that are really rich in energy and can be burned for releasing lots of heat energy. So how do they work? I just said they can be burned. Combustion reaction, we've been talking about this since the beginning of the year. Combustion of anything, whether it's glucose in your mitochondria or wood in the fireplace or a fossil fuel like coal. When you combine a hydrocarbon, a carbon and a hydrogen-based molecule in the presence, and you burn that in the presence of oxygen, it's going to produce CO2 and H2O, carbon dioxide and water. It's also going to produce heat, which is energy. Right? So when you breathe or you burn wood on the fire or you combust fossil fuels like petrol or oil in your car, you are releasing CO2 and you're also releasing water. And if you don't believe me, just go ahead and breathe on your hand and you can feel that the air is both warm and wet. That's the energy and the moisture. And the way it works in a power plant is they capitalize on that reaction and try and trap the heat. So here's an example of a coal power plant. Coal is mostly used to generate electricity in the United States. So the coal is mined and transported to the power plant. It's then pulverized and burned inside of a boiler. And as it's burned here, it's going to heat water that is pumping through pipes that go through the boiler. And when we heat water, we know that water turns into steam. Steam is going to travel through this tube here. And as it starts to cool, it will condense and turn this turbine, which is kind of like a windmill almost. So the steam will turn the turbine. That turbine is connected to a generator, which will help generate electricity. As the steam cools, it will condense back into water and it will recycle back through this system. That will come into play later when we talk about thermal pollution in nuclear power plants. And remember that the emissions that are released as well, we're burning coal here and trapping the heat, but all of the particles, the pollutants like sulfur dioxide and mercury get released through this smokestack here. So don't forget about those two things. And this is true for a natural gas plant, an oil plant as well, although oil plants don't really not as popular. Oil is mostly used in cars. So speaking of which, what do we use fossil fuels for? Oil is in dark blue, or petroleum, is here. And you can see that most of petroleum is used for transportation purposes, like cars and planes. Some of it is used, the yellow is industrial, for industrial heating or electricity generation. Natural gas, on the other hand, the second fossil fuel, is used for a mixture of all sorts of things. Not much transportation, but we see a lot of residential and commercial heating, industrial heating, and electricity generation. Coal, on the other hand, is used almost exclusively for electricity generation. So we see natural gas is the most versatile, coal is the least versatile, based on this. Okay, so what are the types and what impacts do we have? Well, spoiler alert, they're right here. Petroleum, natural gas, and coal. And what are the impacts that they have? There's also peat. I mentioned peat before. This is sort of like the youngest of the fossil fuels. Peat is a very young fossil fuel, can be burned for energy. A lot of issues related to peat in terms of harvesting because it produces a lot of greenhouse gases. Harvesting destroys the ecosystem, which leads to loss of biodiversity. There are severe, not forest fires, but peat fires that can occur because this stuff is very flammable if it's processed improperly. Harvesting it can degrade the land and reduces carbon sink. So a lot of reasons not to harvest peat. Coal, on the other hand, is everywhere, or not everywhere, but it's very abundant and it's pretty dirty. It was the largest source of the electricity in the U.S., although it is shrinking in terms of popularity, and it is mined through strip mining and mountaintop removal. We mentioned the different types of coal in the last video, anthracite, bituminous, and lignite, and I said that as you pressurize heat or as you pressurize peat and add heat to it, it transfers to lignite and then to bituminous coal and anthracite coal, which is the purest, most energy-dense form of coal. You should memorize that. Like I said, lignite is often used for electricity generation. It's not great. It's not very pure. Subbituminous, some people distinguish between bituminous and subbituminous. You don't really have to, but it's used for electricity generation and metalworking. It's the second most common type of coal. Bituminous coal is used for electricity generation. It's the most common type of coal. And anthracite is extremely rare. It is very pure and produces the fewest amount of pollutants. So it's used for domestic heating, burning inside, because it produces the least amount of air pollutants. Coal is found all throughout the United States, primarily in states like Wyoming, North Dakota, Colorado, and also in the Appalachian region in the mountains, West Virginia, Virginia, Kentucky, Tennessee, Pennsylvania, Ohio. That's where most of the coal is in the United States. Coal, lots of advantages. First of all, there's a lot of coal. It's easy to extract, relatively low cost and low tech to mine coal. It's safe to store. You can just throw it under a pavilion. It's not going to explode randomly. It's easy to transport. You don't need pipelines. You can throw it in a train or a truck and just travel it across the country. It doesn't need to be refined, really. You can just kind of throw it into the furnace right away. Disadvantages, however, number in the high numbers, lots of them. I was going to say thousands, although I'm not sure that's safe to say. First of all, it's non-renewable. We're going to run out of coal eventually. There's not an infinite supply. Mining is very invasive. Mountaintop removal does a lot of damage to the ecosystem, but there are also issues with human health in relation to mining in terms of developing lung issues. Burning coal releases a lot of air pollutants, not just CO2, which releases, which is a greenhouse gas, but also other air pollutants like sulfur dioxide, nitrous oxides, and mercury, which can lead to lung and health issues. They can lead to the formation of acid rain and smog. So coal pollution is more than just climate change. It's also about the quality of the air that we're breathing. CO2 isn't dangerous to breathe, but these other things are. It also produces a lot of residual ash, particulate matter, and that gets stored. It's often like a sludge. In Knoxville, Tennessee, there was a huge spill of ash sludge through the community. It took a long time and a lot of money to clean up. You may have heard about clean coal, both from politicians and in the media. They talk about clean coal, what that is, and how clean coal is going to save the country. Clean coal is actually not a different type of coal. Clean coal is coal, but they call it clean in terms of the way it's processed, because when you process it, you're trying to trap the pollutants that are being released, and you're trying to trap the carbon dioxide that's being released to reduce the pollutant impact. It's very expensive and very difficult to do. It hasn't really been implemented on a large scale, although there are lots of pollution mitigation techniques we use that we'll talk about later this year. Anyway, moving on. Petroleum, also known as oil, is a third fossil fuel we'll talk about. It's a fluid mixture of hydrocarbons, water, and sulfur. It's formed from decomposing and pressurized phytoplankton, usually. It's used to heat homes. It's used for transportation. It can be extracted through drilling, whether it's onshore or offshore. And it's used to make anything that you can think of, all sorts of fuels, obviously diesel, gasoline, jet fuel, but petroleum is also what's used to make plastics, asphalt, DDT, which is a pesticide, kerosene, nylon, styrofoam or polystyrene. All of those things are made from petroleum. The advantages of petroleum is that it's cleaner than coal. It produces less CO2 emissions, 15% less, and it's fluid, so it's more suitable for automobiles. You don't see many coal-powered cars out there. The disadvantages, however, are, you could probably guess, oil spills are extremely detrimental to ecosystems. Shortages of oil can lead to war. You can transport it via pipeline, but with leakage and stuff like that, it can lead to habitat destruction, habitat fragmentation, and also infringement on indigenous lands, which I'll talk about in a little bit. It's extremely flammable, so it's not easily stored like coal. You can't just shove it into a warehouse. You have to make sure that it is safe. It has to be processed and refined through a distillation process to get pure forms of oil. You start with crude oil, and you have to refine it into different forms of oil that can be used in cars versus planes versus trains. And it's also a bad air pollutant, releasing sulfur and heavy metals like mercury. And it releases CO2, of course. Some examples of oil spills include the Exxon Valdez oil spill in 1989 off the coast of Alaska. Tens of millions of liters and gallons of oil released. Hundreds of thousands of animals killed. The ecosystem was absolutely destroyed. Deepwater Horizon, much more recent, in 2010 in the Gulf of Mexico, BP released 206 million gallons over 87 days. Thousands and thousands of animals died. It's, the ecosystem's still recovering to this day. It's really pretty messed up. And additionally, like I said, the pipelines that are used to carry that oil have a lot of problems associated with them. One example is the Keystone XL pipeline, which in 2021 was the permit for it was revoked by President Biden on his inauguration day. This pipeline was about to be proposed to be 1,200 miles long, transporting 830,000 barrels of oil a day. And it's a huge symbol for our increased dependence on fossil fuels when our country and our world is trying to shift towards more renewables. It was canceled by President Obama, it was reopened by President Trump, and then recanceled again by President Biden. And throughout all those 8 to 12 years, it lost many other legal battles in terms of its development and its meeting environmental regulations in both Canada and the United States. The economic profit of this pipeline is unsure. The global oil market is down, particularly after the coronavirus pandemic. And extracting and processing oil from these oil sands here, where the oil is located, is a lengthy and expensive process. The refinement process is much more in-depth and difficult than simply just extracting oil from an oil deposit underground. It's not as easy and more expensive. And on top of that, it cuts through indigenous land in both the United States and in Canada. So there's some social justice issues going on there. There's massive leaks with the pipelines, 380,000 gallon oil leak in North Dakota from the Keystone Pipeline, that's a lot of oil. Can have significant impacts on the ecosystem. And there's another pipeline you may have heard of. The Keystone Pipeline's in green. In red is the Dakota Access Pipeline, which has a similar story and gained a lot of fame and attention in the media a couple years ago because it cut through indigenous lands and the Standing Rock Indian Reservation that borders North and South Dakota. This pipeline cuts through. There was leakage on that pipeline, and there were a lot of protests as a result from the indigenous community in that area and from around the whole country. You may have remember the social media phrase, "I stand with Standing Rock." So there are a lot of issues with these pipelines in terms of them cutting through indigenous land and violating the rights of both the people and the environment. All right, so why don't we take a break real quick, and why don't you give a shot at this math problem? Population of the United States is about 320 million people. If we consume annually 24 barrels per capita, that's per person, and there are 42 gallons in a barrel, calculate the total annual consumption of petroleum in gallons in the United States. Good luck. All right, so with dimensional analysis, unit conversion, you want to pay attention to the units, right? The answer that we're looking for is in gallons, right? So we need to take these pieces, 320 million people, 24 barrels per person, and 42 gallons per barrel to sort of fit a puzzle piece together to get things canceled, right? So 320 million people, 24 barrels per person. If we multiply those two things, people will cancel out. 42 gallons per barrel, if we multiply that in as well, barrels will cancel out and just leave us with 322 million gallons. All right, moving on. The last fossil fuel we'll talk about is natural gas. This is used for industrial processes, electricity generation. A lot of it's used for natural residential heating. It is found deep underground, and it's almost entirely methane, CH4, which is a very potent greenhouse gas. If you have a stove that has a flame on it, it runs on natural gas. Natural gas is used for a lot of things, like I said. A lot of it is heating and electric power in the residential and industrial sectors. The advantages of natural gas, it's cleaner than all the other fossil fuels. It does not release sulfur, mercury, or particulate emissions like ash. So that's a huge bonus. And it releases very little CO2 if it's burned properly, which is another huge bonus. It can be collected from fermenting animal waste in landfills through anaerobic digestion. Bacteria will produce methane, which you can trap, harvest, and sell. It is not infinite, but because of stuff like fermenting animal waste, it's somewhat renewable. Not renewable, but it's more renewable than oil or coal. You can very conveniently deliver it via pipeline because it's a gas. There are a lot of disadvantages, though. First of all, it's a greenhouse gas, methane is, and it's 80 times more potent than carbon dioxide, right? So one molecule of methane is about as bad as 80 molecules of CO2. The gas can leak during extraction. You can see some of it here, and it's not a gas you can see, so it can leaking. There are many plants that have shut down, natural gas plants, but are still leaking gas out into the air, which is really bad because it's 80 times worse than CO2 in terms of greenhouse effect. The burning of this gas produces nitrous oxide, which is a precursor to smog. We'll talk about that later in the year. And fracking, one of the methods in which natural gas is extracted, is extremely environmentally dangerous. I'll talk about that in the next slide. And natural gas smells like farts. So that's pretty bad. So methane levels have soared to a record high recently. Take a look at the date here. Some of that is from the cattle industry, of course, but some of that is also from methane harvesting and methane leaking, right? So you can see over time that the amount of methane in the air has increased dramatically, and that's really problematic because it's much, much worse than carbon dioxide. Traditional methods of extracting natural gas, you drill down into the ground and you drill into a reservoir of natural gas and it just seeps up into the pipe. But you can also use something called fracking. There are actually gas bubbles that are trapped in a type of rock called shale, and you can extract that gas by basically sending a pipe down, cracking that rock open, and extracting the bubbles that are trapped inside. And that's called hydraulic fracturing, also known as fracking. It's pretty new, relatively speaking, and you dig a giant well and you inject a pressurized liquid filled with water, sand, and chemicals into this well that runs horizontal at the bottom, and it cracks the rock down at the bottom, the shale, and releases any trapped methane gas that is in the rock that can then go back up to the pipe and be harvested. Here's another diagram showing the same thing. There are some problems with this, though, in terms of fracking. One of the problems is that it can contaminate groundwater. Not only the methane, the natural gas as well, can end up in groundwater. You can see this woman here is able to light her tap water on fire because there's methane inside the water. But there's also fracking fluids, right? All of those chemicals that are being used, sand, acids, etc., that water can leach out into the groundwater and contaminate and make it toxic to drink. The methane can leak not only into the groundwater, but into the air, as I already mentioned. Fracking releases volatile organic compounds, something we've mentioned, but we'll get into more detail next semester, or sorry, next unit, but it leads to the formation of smog. Injecting the wastewater, all that wastewater with the fracking fluids oftentimes need to be stored somewhere, so many companies will inject it back into the ground, and it can actually lead to earthquakes from the injections. It's something noted in Oklahoma. The wastewater, if it's not injected into the ground, is sometimes sold as a de-icer to help keep roads from icing over in the wintertime. Problem is sometimes it has radioactive particles in it, so then you're spreading radioactive waste all over your public roads, which is really, really bad. Fracking uses a lot of water. Between 70 and 140 billion gallons were used in 2011 in the United States for 35,000 wells. That's wasteful of a lot of water that we can't really get back. I mentioned already that the fracking can contaminate groundwater. Okay, so given all that, why do we use fossil fuels, right? If there are all these downsides. Well, it's easy to access, whether it's coal, oil, or gas. There's a lot of it, and it has something called a high EROI, an energy return on investment, meaning that it's cheap to get, and it produces a lot of energy. So you're getting a lot of bang for your buck, right? EROI is calculated by taking the energy obtained from the fuel and dividing it by the energy invested to obtain the fuel, and that can include financial resources. So, for example, if you obtain 100 joules of coal and it costs 5 joules to extract the coal, the EROI is, that's right, 20. 100 divided by 5 is 20. Therefore, a higher or a lower number is going to be better for a fuel source. That's right, a higher number is better. Anything below 3.0 cannot really be considered a viable energy source. So if you look at the EROI of different fossil fuels, you can see coal and oil have pretty high EROI values. Coal's close to 50. But if you're getting oil from tar sands or oil shale, you can see that the EROI drops substantially. And that's why the Keystone XL pipeline is problematic, because the EROI on that oil that they're extracting is significantly lower. If you look at the energy return on investment values for oil over time, you can see that they're dropping. Right? Oil is becoming less efficient over time, and that is due to a variety of reasons that we'll explore in class. And another thing you should know about EROI and why we use fossil fuels is because of something called subsidy, which is basically financial support from the government. The government will spend money subsidizing the fossil fuel industry to make it cheaper to produce and distribute these resources. So in 2017, $5.2 trillion was spent worldwide on fossil fuel subsidies. In the United States, we spent $649 billion on fossil fuel subsidies, second only to China. That is more than double our military budget and more than 10 times the education budget for the entire country. Fossil fuels make up 85% of all global subsidies, and it artificially lowers the price of these fossil fuels. So reducing these subsidies would have lowered carbon emissions by 28% and fossil fuel air pollution deaths by 46% and increased the GDP, economic revenue of these countries by 3.8%. And the reason for that is because there are all these negative externalities related to fossil fuels: air pollution, healthcare costs, carbon emissions, the dangers of mining, etc. So removing these subsidies will reduce the incentive to use fossil fuels, and it will help reduce all of these issues and make the country a better place. Renewable energy like wind and solar is cheaper every day. Onshore wind has dropped 23% in price since 2010. Solar electricity has dropped 73% in price, and they're becoming more efficient every day. So at this point, there's not a lot of excuses to us for why we're still using these subsidies. And if you take a look, you can see subsidies have actually increased in time. This is the different bars here. The subsidies have actually increased in time over the past 10 years or so. So hopefully we can move in the direction of getting rid of those subsidies. That's all I've got for you now. And over the next 2 days, we'll be learning more about fossil fuels. So if you've got questions, bring them to class. Otherwise, I will see you then.